Lorenzo should be probably joining us later. I wrote him. Okay, I was now discussing with Roman about the file size. So, sorry, as I understood, we have a limit of 1 megabyte. After 1 megabyte, can you?
Yes, we are. Can you hear me?
See, what I want to silent Frederick. Okay. See, tell me.
We have for every file we have a 1 megabyte limit, and in exceptional case it can go to 2 megabytes, but it's 1 megabyte limit per file. If we have a bigger file, like I don't know, maybe an STL or something that needs to be big, you have to put like a small version of the file, like if it's an STL, a low mesh version on the archive, so you have to push it, and then you put a link to an external system like Dropbox or Google Drive with the actual size model. So you have a lower resolution file inside the archive and a high resolution outside.
Okay, perfect. Okay, one second, I'm telling you. Sorry? There is a question.
Yeah, is it okay to use zip file, compressed file?
Yeah, understood. I couldn't hear. It was great.
Like if you can compress with a zip file or something. Yeah, but I mean, you will, if it's an STL or something like that. How much can you go down with the size? I mean,
the problem is that 1 megabyte is quite it's very small, no? As a size. So I don't know if we can compress.
I don't know. I don't think so. I made all my files in the Fab Academy last year were not more than 1 megabyte. Maybe there was an STL that was 6 megabyte, and I put it outside.
Okay.
If I can just add a comment, with the STLs or Rhino files or stuff like that, making an archive doesn't really affect the size. I tried it already, so it doesn't really work to make a zip.
I think so. No, so basically you were just, I mean, you managed to have all files lower than 1 megabyte in my Fab Academy, but if you manage, good. In any case, I already sent to everybody files that are above. And nothing. I mean, they know that they need to put externally all the files that are above.
In any case, every week, every student should. In any case, every week, every student should upload not more than 10 megabytes. So, I mean, you have a single file limit of 1 mega, but then you have a week limit of 10 mega. Okay. So every week, every student can upload up to 10 megabytes. So maybe sometimes if you have, I don't know, maybe that week you just uploaded nothing, and maybe you can upload a 2 or 3 mega file, single file, because your limit is 10 megabytes for all the file you have, you know. Like it's a little bit up to you, up to your common sense, you know.
Va bene. Okay, in any case, we will be checking the size of those files, doing the review. Let me see. Academy 2016. We still have a bus page, and we need to have something uploaded before a NIRF class, I will say. So is a bus coming there to volume before the class? right? Because the class is there in volume today.
I think we'll be there at 2:30.
Okay. At 2:30. 2:30, no, it's too late.
But I can try to do the first push with him today. It's me 1 hour for him to get on.
See, yes, if you. Yeah, even if it's a basic push, let's do it, because I mean, also the FAB Foundation wrote me that they are changes, and they already asked me about Abbas and Vincent. So let's do that.
Excuse me, where is Abbas? Is not connected now?
To be totally honest, he's asleep.
Asleep. No, okay.
Yeah. Why not? Okay, and apart from this, Vincent is joining probably next week. We need to understand what is happening with Francois. I wrote him, but he didn't wrote me back. So let's see. I'm gonna start with Thomas to do the review. I'm sharing the screen.
Okay.
Tell us.
Okay, so this week was a little bit complicated for me. I thought it wouldn't be that complicated, but I had a lot of little problems during the assignment, but I learned a lot, so it was good. So we started. I started by explaining what we did with the printing, but we started the other way around. We started with scanning last week with Ludovic. But anyway, so we at WOMA we used those printers, which are WebPrep printers. It's called DOM. It was made by a guy called Dude. So it's like a kind of homemade printers, but they work really well. And so the first thing we did was to scan ourselves using Kinect. So
I go to the scanning part. Okay.
Yeah, it's at the bottom of the page.
Okay.
So we started using Scanect, which is a software that we use to connect the Kinect with the computer. And we made a few tries before it actually get us some satisfying results, because at the beginning we were trying to move ourselves in front of the camera would be being fixed, and so we were spinning around ourselves, but the result was not really precise, and I think it's because we were really stable base to spin around. So we were moving like that, so the image was quite imprecise at the end. So we decided to make differently, and so I stood stable, and Ludovic was turning around me with the camera, and so this way we got a pretty better result. So after this, we directly exported the file into a STL, and I edited it with Mesh Mixer in order to fill all the holes that was in the mesh, because there was a lot of holes, especially on the head, in my hair. And so I used the make solid function that we can see here. And after that, I edited my scan in Rhino in order to add some details, add a pedestal, add some, so that I had this little statue. And to finish, I also modified it in Blender using the Sculpt tool, which you showed me, and it's really nice, because you can add a lot of different details, you can modify a lot of stuff, and it's quite easy to use, I think. So yeah, I did a lot of modifications, and after this, I generated the G code to print the bust. So first, I did a really small version, because we just wanted to test the parameters of the printer. So it's like 3 centimeters wide, and it's the result here. So it's quite small, and you cannot see a lot of details, but it showed me how the the printer works and how the parameters can affect the result of your print. So basically here I put a really high speed for the print.
No, not enough filament.
Yeah, not enough filament on this one. We left it. We left it on Friday night, and when we came back on Monday, it was like that. So this was the first problem I had. And also you can see here that the filling is quite quite dense. It's way too dense, so it took like 6 hours to print. So this is a good good mistake, because it showed me how it can be done differently. And also you cannot see it here, but on the other side of the bust, I put a Fab Academy inscription, but it was extruded from the base rather than being engraved, and so it wasn't really printed well because it was outside of the object. So
no, what is it? Which part?
You can see there's a Fab Academy logo, and on the other side, I didn't take a picture, unfortunately, but it was written Fab Academy, but it should have been written engraved and not extruded. You see what I mean? So it doesn't stand because it's like outside the bust. So
okay, I understand.
So there's no support on the letters. But anyway, so after this,
then you went back to 123D Catch. Why?
I just wanted to try it, but and each time actually didn't. The application is still running. It's still finalizing.
It's not working.
It doesn't work. And so after that, I tried to design an object that could be non-subtractive and that could be printed. And first, I tried to design this bracelet that you can see. Sorry. First, of course, we did the try with the.
Sorry, okay, I should go here, no, for the bracelet. That's the
for the bracelet. So I designed it in Illustrator, and then I transformed it into a 3D model using Rhino again. And the problem was it's not really printable as it is, but because of all the holes they are in it. I was not sure at the beginning it would be printable, so I asked Guillaume, and we said, okay, let's try to do it. Maybe it will work, maybe not, but let's try to do it. And also I wanted to print it with Filaflex because it's a bracelet and I want it to be like flexible. So we tried with the orientation you can see here, but the problem is it's not really stable because it doesn't really touch the base on a wide surface, a wide enough surface.
On the other way around, rotate it.
Yeah. On the other way around, Guillaume told me it wouldn't work, so we tried this way. But the problem is when we began to print, it was moving on the base while being printed. So it didn't really work. So we stopped at 5% of the print, and I did another model. You can see the picture here. So this is the first test. I also had a lot of problems with Filaflex because it wasn't extruding well enough. It's quite tricky to put the filament correctly in the nozzle, and secondly, it was quite tricky to set the right temperature and the right parameters to use it correctly. And so the picture you can see here is the result of the test we made. So we had to stop because it was moving too much. Then I made another model. This time it was completely full, no holes. And instead of having this holes pattern, I did waves on the surface of the bracelet.
Or is it the paneling that you
Sorry?
Is it the paneling?
The paneling?
Mm-hmm.
What do you mean?
To every surface face. You just have divided the surface into U and V coordinates, and
no, actually,
geometry to every.
I made some curves at the beginning with a particular angle, and then I made a surface out of them. So that, and I duplicated, and then I end up with this result. And then
result of a loft, or it's a morph that you are applied to the surface.
I made some waves by hand, like 4 different lines with curves, and then I made a surface, and then I duplicated them. It was flat at the beginning, and then I did a twist. I don't know the exact command. I don't remember, but it was flat. I made a cylinder, and then I wrapped the surface around the cylinder to make it with this shape. And so this time we set the parameters of the printer with higher speed. So you can see the parameters here, and it took like 1 hour to print, but it finally worked, except that the printer stopped 2 times. So you can see here the result, and we didn't understand what was going on at the beginning. So I was quite I didn't know what to do, but in fact it was the USB cable connecting the computer to the printer that was faulty. So it stopped the first time, we began again, it stopped the second time, and then we changed the USB cable, and it finally worked. So here's the final result.
And what about the size?
The size, actually it's a little too small to be actually worn as a bracelet. I tried with my girlfriend, and she couldn't put it, but at the beginning I wanted to print it with Filaflex. With Filaflex it would be fine because it's like extensible a little bit. So maybe I will try later to print it with Filaflex to see if it works.
Okay, thank you, Thomas.
Welcome.
You didn't wrote anything about the group assignment, so about the understanding the design rules of the printer and why they affect your print. I mean, the model you are going to build. Right?
Actually, I wrote a little bit at the beginning about the crash test we made, the first one, on the top of the page. But yeah, maybe I didn't explain enough how I understood what was going on with the print.
Printing. So it's a tolerance test recommended by Neil. But I mean, there's a screenshot. Okay. Maybe point out a little more that this is the not designing and printing, but this is the first step of understanding how the machine is made and what is the capabilities of the machine, what are the design rules. Okay, so just make a title for it, and then you start with a paragraph for design and printing. Okay. These are things that can be done later, of course.
Sure.
For the parameters, everything is here, no? I see. So you post it here for this one as well, which is good to have. Yeah.
Here it's a slideshow, so you can see there's a lot of screenshots.
No, I see. I think it's quite. Thank you, Thomas. We're gonna move.
Sure.
So probably let's see if we can switch between Ayasio and Woma. Lorenzo, do you want to one of the students so you don't wait for us to finish?
Well, to be honest, I think the students are still working on documentation, So, I mean, we have some objects here, but we are still work in progress. I mean, you can go ahead if you want. I don't know, unless you guys,
My pictures aren't updated. I need to update my pictures.
No, I mean, they're still working here. I'm sorry.
Okay.
One thing,
Okay, no.
sorry, one thing, Thomas, your zip file is linking to the Wik3 zip file. So your source file are the one from Wik3. So
okay,
maybe you have to change the link.
Yeah, okay, will do.
And one thing you can do when you put when you do screenshot of your preferences and your options from your printer, for example, you can also export a .ini file that is a configuration file. So one can just take it and upload it to his Cura or Slicer and use the configurations.
Okay. Okay, good to know.
Okay. Wait, I also say hi to Mathieu. Matt, are you in volume? Are you guys there, both of you? Saverio, I see you smiling, but Mathieu, can you hear me? Okay, that's the answer.
Okay. The answer is I'm
this,
here.
Yes. Very nice, very nice. Okay, amazing. Okay, let's move on. I'm gonna take. Fred, are you there? Save.
Sorry?
Okay. Now I can hear Frederic. Frederic, are you there? Can you hear me?
Yes, I am.
Perfect. So, good morning. How was it?
On my side, you mean?
See, from your side. We are checking.
In fact, the week was a bit busy. I did not go to the Fab Lab. Because I bought a 3D printer in kit. One of my aim was to build the printer from the kit. It took a very long time to do it. I think about 15 hours to build the hardware. And then, after building the hardware, I think I finished last Monday. Then I started to use it. I encountered few issues with my first printing jobs. So I had to solve few issues. I had first to solve an issue with the material feeder. I did not correctly implement it, so I understood more how it works, and finally it was okay. Then I had a problem with my wire axe, which was not enough tightened. Mm-hmm. So it made sometimes the wire axe turning into void. So it gave very strange printing. I heard about Cura a lot. On Cura, with this Ultimaker printer, is very integrated. So it's cool to have such a software. And finally, yesterday I discussed with Saverio on. I did a very simple object because I was trying to print a complex test file without success. So with Saverio, we decided that first step it would be better to go to a simple simplest simpler object. So we just design a simple cube in Rhino. I did a print of this cube. Result this time was not so bad. Still, I have some tuning to do because the first layers of my object are not good. The head is melting the previous layers only on the first layers. So I imagine I have a problem of bed leveling. At least this. Perhaps also I should tune the temperature of the heated bed to have it less less height. That's it for the printing. I did not have time to design the objects that could not be made subtractively as asked by Neil, but I have the plan to do it soon. I also did 3D scanning. This part I just installed 123D catch on my smartphone. I did a scan of the only object I had with me in Paris last week. It was my my trip bag in my room. So I did several photos of it. But honestly, this software is very easy to use. The Autodesk platform is doing all the processing. So I did nothing except installing the app, taking photos, registering to Autodesk website, loading the photos, and waiting for the post-processing, because post-processing on Autodesk platform is taking a lot of time. And then I got the I had the preview of the 3D scan, and also I had the 3D models. I download them, and I was able to open it in Rhino just to see the result. But I did not go further about it. This week I spent, in fact, a lot of time on building the 3D printer, on doing the first tries on it. But
what was the most difficult part?
Sorry, what was
the most difficult part in building the 3D printer?
The most difficult was the extrusion head. It's a bit tricky to build this part because there is not so much space on all the parts must be very tightened. This part was not so obvious, but globally, I think the notice of this printer is very nice. It is already the version 4 of this printer. It's an old model, but still up to date. At the end, the two mistakes, the two issues I had were on my fault. I did not tighten enough the one pulley on the while motor. I did not understood how to close the filament feeder. So it was just two mistakes I did. But globally, if you follow very strictly the notice, you will achieve it. Only extrusion head is tricky.
Okay, Saverio, in terms of assignment, is it matching all the requirements for the being?
No, it's not complete because you need at least. I mean, when you you build your 3D printer and then you have to check the design rules. So you have to see if what are the rules for this machine. But I think, I mean, since you built it, you are very able to do it because I mean, now it's your printer because you print it, okay? And so you know everything about it. And then you need to make a model that you can only do with a 3D printer. So and once you do it, you can print it. For the scanning, I think it can be good. Maybe you have to take the model you scanned and work on it a little bit to make it like, I mean, look like your bag. So you have to remove the floor from the model, change the shape, and blah blah blah. Maybe you can do the scan again if you think it will be better, or maybe with a simpler
option. Also, I would like to see other softwares. I've been saying to use Memento, SFRM. So I mean, it's good to check because from 3D Catch, I personally also had a lot of issues during all the week to use it, and Memento really looks like it's working. And also the SFRN, it's quite nice. It's a little bit more tricky. It has a worse interface, but also gives you a point cloud, not only the final thing remotely the images, but it's doing it.
Also, you can, I mean, when you have time in the next week, you can just make a scan with the Kinect in WOMA. So you can also try a different approach to 3D scanning.
The students, all of them have evaluation criteria, no? Sorry?
Yes.
Did we share with them?
I'm doing it. For now, I just did it on the instructor only list, and I'm going to make a little change on it because I was doing it in numbers like 1, 2, 3, but I prefer to do it in like words, like completed this, or you need still do this part, blah blah, and then we are going to put it in a document that all the students can see and can access. So it's something I'm going to do between tomorrow morning and tomorrow afternoon.
Okay. Yeah, but it's important that they see the evaluation criteria for every week. In any case, I really appreciate a lot what Frederic did. I think it's the best way even to approach the 3D printing week. His own 3D printer. I would like him to now to move to the other phase, which is designing his own object and exploring a little bit this scan. I don't know, Frederic, are you sharing also some file? Where is it? Also the sharing part.
I did not put the file.
Sorry. Okay.
I did not put my files on the site. I will do it, but I did not understood how to do it because it's very big files. So I have to put it on Dropbox. That's it. And I put a link to Dropbox, for instance.
No. Don't put them in Dropbox. Let's. If we are going to use external links, I will say that we should have a GitHub account. Romain, what you think? No? Than using Dropbox.
For me personally, I use Dropbox, but the problem of Dropbox that once I don't know, I will remove it. So we need to find the central location that will stay stable when you push, and it's okay. So it can be something else. It should be something else than Dropbox. It can be temporary solution, but.
No, let's not use Dropbox because I'm telling you, because I use Dropbox and now I need to relink all my files, my folder at the end, and now I need to relink everything again. So it's better to have everything online in a remote archive. Okay. Also, I like, in terms of documentation, Roman is next, but I want to Thomas page. Do you see my screen?
Yeah.
No. I'm gonna share. Okay. So Thomas has this part.
Yes.
Right, where you are putting external links and the software that you are using, and the link of the source file, Thomas. Can you hear me?
Yes.
Okay. Let's add. So this is kind of the structure of the, let's say, the ED card of your assignment, and we don't where in the documentation. Okay, just a quick comment, which is still valid also for Frederic. And let me same situation. Is it clear? It's clear, no? Nothing of the other, no rocket science. Let me see.
It's just that I didn't hear all of what you said. It was.
I'm saying that. Thomas, I said that we should put we should use this first part as an ID assignment. Okay, so you have precisely as you did. You have all use also the hardwares and.
Aldo, your audio is going up and down.
I'm moving up and down.
Your audio is like sometimes we use.
It's broken. Yeah. Okay, Saverio, can you say?
If I understood well, you want them to like put the assignment on this little box, also like the title of the assignment, and also like the caption for the title of what they did, something like this.
I want them to put the link to their file here. This
okay.
part.
Okay. Yes.
Okay. So I don't need to search for the link of the file
at the end.
The page or in another place. Okay. So this is also for Thomas. This is for Frederic. It's for everybody. I want to check if Roman.
Same for me. My file is down on the last line.
Okay. Okay. No. Let's add everything here. Makes sense to keep working that way. Okay. My comment. Tell us about the week.
So yes, the week was very busy. It takes a lot of time, but I did in fact my parcours of this week was quite same as for Frederic, except that my 3D printer was finally not working yet. I have a problem on it's a Prusa E3 Hephaestus. And I build it from the kit, and it doesn't work because one of electronic part, one of the driver.
Is there any picture?
No, I didn't take it. I didn't.
Okay.
If it doesn't work, I said okay, let it as it is. So it doesn't work. One of the driver doesn't give enough intensity of electricity, so the motor of extrusion doesn't turn. So signal doesn't make it turn. So when I switch X-axis and extruder motors, it works. So it's problem of extrusion. And if somebody will buy the Prusa E3 Hephaestus printer, never use French support. It doesn't work.
Mm-hmm.
So yes, assignment was in 3 parts. The first part was the group project understand the print and design rules. So what I understood after Saverio did a great presentation, and we see these models test to print. I understood the idea of the 3D printing and the capacity of the printer need to be included when you produce your model. So I try to simplify. I try to simplify these rules, like where from to start. Like each layer need to have support. We cannot print to the empty. Each next layer have add some weight, so the lower level should support it. Say they should be strong enough who have some additional supports and so on and so on. So I wrote it, and then I go to the design my 3D print my object that could not be made subtractively. I said, okay, what does it mean could not be made subtractively? I had two ideas. Have a cube with a sinusoid hole inside. So the hole that passed through the cube, and it's sinusoid, so you cannot drill it in any way. You must cut it on the two halves, drill it inside, and then glue it. So then I said, okay, I will go to something more complex, and I built a cube that is empty inside, and it have three tubes in 90 degrees enter it inside. I designed it in antimony, and it has two parameters: the big size of the cube, and the second parameters, and it's a blend of these tubes inside. So the blades blending ratio, they can be blended in 90 degrees, or they can have some arc inside that give support for the next layers. So by these two parameters.
So these two geometries are connected.
Yeah.
And,
in fact, no, they are not inside. Each one
not
inside another. You can see this on the second image. Or you can use STL from the zip file just to see how it works. This is. Then I make it to print it in 3D. So I put it in Cura. Then I see it's too small. Then I re-extracted it bigger, and you can see the different result. But my 3D printer doesn't work. So what I did, I tried to make a simulation on different applications. If you will go a little bit down, you will see I used the, yes, here we are. Repetier host. It's the tool that permits you to see how it how it will work your model. So you can see layer by layer. It just takes the G code and it play it and it simulate the working of 3D printer. So you can see the behavior of each layer, if this layer has support, and so on and so on. So it's quite just a test.
In Cura also you have this option.
Yeah, I know. If I take just but we should use different software. So I add another one to the list to see if it can give me something monitoring. So in Cura, in fact, if you use this, you can just take G code and from the scratch and show you how it will be printed. So then I passed to the 3D scan. I used Catch 1, 2, 3. I saw that Ludovic and Thomas, they do the Kinect. I said, okay, I will try to 1, 2, 3D Catch software. The goal of the software, the difference with the Kinect is that I'm able to scan the huge objects. So if with Kinect, or really small objects, Kinect, it have the limits. It can scan the object the size of human, I don't know, size of chairs, but it cannot scan the building, and it cannot scan the really small object. And so I passed to it, and of course this software has own limits. I scan my little Yoda, and I pass to the Blender to remove all not useful parts. Then I use a little sculpt to close the hole that appears, and I make a video, just a small moving camera around just to see it. Yeah. So Yoda looks nice. It's really close to the source results. And then I check the limits of this scan. This method of scan is reproducing of restoring of 3D objects from the images. So the images, the simple photo must have texture. I took the really simple object. If you go a little below, it's a thing, you know, the IKEA IKEA thing. It's really
I think we lost Roman.
Sorry, I lost you. I lost Roman. What you said at the end?
We all lost Roman.
Ah, okay. I understood that the object, so the 1 to 3D Sketch is not working with objects that don't have any texture. Yeah? That's what he was saying, no? From this picture.
It's like, yeah.
But also probably from this picture, I don't know if those are some of the pictures that he took.
And then you have all this behind.
But it looks like he was moving the object and not the camera. So this is also some.
Anyway, I really like this page.
You really like?
The work of Roman and the page how we did it. So you have at first you have the design rules, then you have the design of the object made as something that can only be printed, and then you have the scanning. So very easy to follow. Just remember, all the students remember to put yourself in the in place of the guy who's going to make your review at the end. So try to make it simple for everybody to understand.
Yeah, also I would say that it's missing a little bit the time for a sketch, for instance, not giving information about how much time it took for the software to generate the 3D model to have. And also the rework in Blender, it probably can be a little bit deeper, the information that is giving. So what has been done with Blender on the model, apart from we see, I mean, it got some all. In terms of the 3D scanning, I see that there is a part which is in a shadow. So a part of the face of probably was not properly scanned, and he could have used mesh mixer in order to clean the mesh. I see connected. But in any case, you know, there is some extra work that he could have. In general, Roman is very precise with the documentation and that is providing, which I really appreciate. Mathieu, on it? Sound. First, the micro. It's off. Turn it on.
No, I just had a general comment regarding scanning. Most scanning technologies that are using image photos, which are the ones that apparently the students have been using, have a lot of difficulty with reflective materials, so chromes, and also black, so that it's to get back to the texture. Sometimes black is difficult, in particular with the scanners that use the projection of image, black and white image, because black doesn't give the contrast for the software to recognize it. So yeah, it's important. It's to get back to the comment from Roman about texture. Chrome is almost impossible. Welcome back. Impossible to 3D scan with image technology.
Yeah, I tried also the Chrome share, so not possible to scan.
Okay. Just to let you personally, this week I was also working in scanning. We are trying to scan mycelium. So we are facing quite a lot of problems with fungi. And we are trying to use this technology in order to extract data and information on the growth of the mycelium. As I wrote you, we are using other softwares, and not this one. You know, Memento and SFRM. It would be nice if you also try one of those to complete the documentation. Apart from this, I would like to.
Aldo, if you're interested, I have a contact in Barcelona who scans buildings and has technology and is quite an expert on that. That's a parenthesis.
I'm interested. Definitely interested. So we can talk about it. I want to inform Mathieu and Saverio that the other student from Digiscope will probably join us in the lab today because he has a meeting with Ultimaker today, so the students probably will join us in the lab. We're gonna do the class from WOMA or Volume today?
Volume.
Volume.
I'm writing them an email to inform that this is gonna be in Volume.
Who's gonna be here?
Apart from this,
the guys from
their students are coming there.
From the other.
The students from Digiscope are coming in the Volume. I would like to do a review now again about the previous week of electronics, and then we can close probably the review. Keio?
Yeah.
There?
Yes.
Good. Okay, let me go. So I see that I was taking a look and I want the others to give you a feedback. Yeah. Allora, more or less we know how it was, and we know all the work that you did in order to the machine. So I mean, more or less we all know the story. I will say that yeah, more photos is exactly my comment. You know, I guess you did a great job last week. Also quite unique path, setting up a CNC to do all of the electronic with this big machine. I would like, in particular, you to do this process very precisely. I guess it's something that we can use and share with the rest of the FabLab network.
It is completely to do that. Like I need the parameters on the computer at WOMA to be very precise. And basically I shared something very general here, and I'll get into details.
I was thinking today, is there a smaller clean bit? Because we are using 164, no?
Yes.
That I don't know if we have raise the quality of it. Yeah, and I should check. I don't know, Mathieu, Saverio, if you know a smaller bit, then I guess so. But I was just curious to understand if with the CNC we should decrease the millimeter in order to achieve the perfect result. Is it clear what I'm saying?
You're breaking up a little bit, Aldo, so we didn't get all of the sentence. You're just asking if with a smaller bit we can get a better precision with the big milling machine, the big CNC.
Exactly.
I don't know about that, but I don't think it would have a big impact. The precision on that machine is a question of the precision of the motors. I don't think the size of the bit will impact if the number of passes you will do and the width of the grooves you will make, but I don't think you will gain on precision except just in the angles, turning angles, and I don't think that's where the problem is.
No, right. is to start from a PNG, and not an SVG file, to track directly the PNG to see how the machine reacts.
Did you get better results, Guillaume, with the PNG rather than SVG?
Right. Just for info for the students, at WOMA we've got several moments we will this week, next week. Like I took 2 hours on Tuesday, 2 hours on Friday, and 3 hours on Monday, which I can adjust. But basically, I think this time shall allow us to mill the PCB we get to mill this week.
Okay. Well,
maybe the PNG, and afterwards milling the project.
And I have some little problems with the audio. In any case, yeah, I will say that let's put all the information there online, and even to try another way to generate the path out of the fab models.
One question that arose last week, I don't know who pointed out about the fact that the angles, the obtuse angles were rounded where they should have been perfectly squared. Someone mentioned about reducing the speed of the milling machine. Did we try reducing the speed to see if that
was with slowly.
We reduced it a little bit, but we didn't reduce it a lot. Like we have to make one try with a really low speed to see if something's happened, something changed.
Yeah, it would be interesting. Make a rectangle and see what happens.
Yeah. That's what we said last. Chirac was commenting last time as well.
But that was Chirac.
Okay, let's see if this. Let's see if we can have it. We can have some tests this week. Okay, guys, just a little information for the machine design. For the machine, we ordered the material, and from the Fab Foundation, they are coordinating. So I will write them back, and hopefully we're gonna have it for the days I will be there in Paris. Also, Lorenzo, did you have a date from Jean-Luc on the machine design? No, probably it's not there. Well, in any case, a quite complex week, and also the one that you're gonna start now is gonna be intense. You're gonna design your first circuit. So good luck with this week that is starting now. I will. If you don't have any other question, we can close the video today. Another little information before closing. We have with Amsterdam, so I'm trying to set up probably or to change for next time, for next week, so Emma can participate, or we have to do an extra session there, because I personally would like an input.
Aldo, sorry. I mean, we are still waiting for the shipping cost from Jean-Luc. So we didn't have any information actually.
Yeah, let's see, because I mean, Jean-Luc told me that he was going to send us an update. Told us that he was going to send an update. Let's check if there is any news from this from their side. Otherwise, I start to think that we're gonna really be, I don't know, late with this assignment, which
yes,
is very
just a little bit.
Which is very complicated. Is the most difficult.
Would you like to show your page to the FabISP?
Oh, oui.
Aldo, do you mind if from the previous week, I think Gerard did a nice job. So, I mean, if you have like a couple of minutes to watch, to have a look on his page, could be interesting for all the other students.
Okay. Yeah. Yeah. Here we are. Ready. Gerard?
Yes, I'm here. Yeah.
Your week, your presentation.
Yeah, you can present yourself and what you did.
So, for the Electronic Production Week, I used KiCad. I don't know how it's supposed to be spelled, because it's a software that I know already, and it didn't have any limitation like Eagle, which I don't like at all. My first idea was to do a new design of the FabISP. That's what I detail on my page. An issue which I face is that the traces and the pads was too fine, and the milling was bad. So this test was a fail. So I just take an already done FabISP board, just added my name on it, and all went fine since. One mistake I made when I was soldering the component was that I inverted the orientation of the microcontroller. So when I tried to desolder him, pads and tracks come with the chip. So I had to do another board. I don't do another board, but I just repair the thing as I can. So that's why there is a solder blob and a wire running through two pins. But the board went fine, works okay, and we used my board to program the other boards. So all was okay.
But sorry, why the path were too small? Was it a problem of the software, or how you were generating the PNG?
I think it's my fault for first, because I used very thin traces on first.
Okay.
So like it's said on the page, some traces went fused together, or
they broke.
The part was fused together. And I think footprints on KiCad were a bit too thin too. It's certainly usable, but more difficult to solder. I don't have time to try that.
In KiCad, you can control the size of these traces, right?
Yes, we can. But I have taken the plan B to have something to present, and more surely.
Good.
Yeah, and
also very good presentation.
I'm sorry. The footprints on KiCad cannot be adjusted. It's the footprint from the elements, or
they can individually. So it takes a lot of time to change pads size, and or we can just modify the component and re-import it.
Yeah,
it's a long process.
Okay. Yeah, but then you can reuse it after. Okay.
Yeah.
Very good documentation. Also,
thank you.
I mean, also, documenting the mistakes.
I think it's important.
Yeah, I never seen it. It's very good. I will also say to our students to take note of this BDB, which I really appreciate. It's very good. Well, we can try. I mean, this is a nice input. We can try not to use, or at least someone can try not to use only Eagle, but also to use KiCad. As you are writing here, it's a project that also CERN is.
Yes. The software has greatly improved since the CERN is involved in the development, because they are adding very useful functionality. It's still in progress, and there is a roadmap. I think it's a good thing for this software, I think.
Yes, I just want to point out, as you said, Gerard, that Eagle on the free version has some limitations. Yes. And one of which I just became aware of, and I'm concerned about, is the size.
Yes.
Yes. To 5 by 5, which may be a concern for final projects. Up to now, it's won't be a concern for the next couple of weeks, but if you want to make your own Fabduino, then it's going to be trickier to fit within 5 by 5.
Centimeters or inches?
They lowered the size board limitation?
Yeah, for the free version.
Oh,
that's what I just
Il me semble qu'avant c'était 10 cm. Before it was 10 cm.
Yeah, it was much bigger.
Yes.
Or it was bigger.
When is sorry? When it
changed?
Reduced. Not in our Mathieu. It was not reduced in our Fab Academy, not even last year. It was still big.
Yeah.
It's something new that
okay, I didn't check because my Eagle is installed and now doesn't have that limitation to 5. But Fabien said it was limited to 5 by 5, and I didn't double check.
It's something new this year.
If it's 10 by 10, it shouldn't be an issue. If it's 10 by 10, I don't think we will have a big problem. If it's 5 by 5, we may need to look at KiCad. That's all.
Yeah, if it is 5 by 5, everything change. I agree, absolutely. So probably this become the best option.
Okay, I just checked on the Eagle website, and it's 4 by 3.2 inches, or 10 centimeters per 8 centimeters.
Okay, yeah, it's always like that.
Okay. So that's fine. No issue here.
Okay, no, I heard. Okay. Good, thank you. Thank you for the check.
Last thing I want to just point out, one of my students, Fridjof, was able to find a nice software online. We're still trying to figure out how to make it work with the CopperCam that we have here for the Roland MDX40, because we are using, beside Fab modules and the CopperCam as software, depending on the situation. So we are using a software that is called EasyAda. I don't know if you ever heard about it. EasyAda, something like this. Oh, let me open the chat. Like this. EasyAda.com.
Yeah, EasyEDA.
EDA. Oh, sorry. Have you ever heard about it?
No, me no. In any case, Lorenzo, I mean, your voice is broken. I don't know if it's with me or the others can hear you properly. I can't hear. No, I can't.
Can you hear me now?
Yes, now yes, but a lot of parts that you were, a lot of things that you were saying before.
Oh, sorry.
Yeah, I will close the regional review, but sum up. What is this software, and what is doing?
Well, just to point out that we found this software. Not me, I mean FreeJob. My student here found this nice software that is online. It works fine. We can have like a Gerber file too. We had some issue in order to upload it, this Gerber file to Coppercam. That this is another software that we have here with together with the Roland MDX40. I mean, the good thing is like it has all the libraries, all the tools. It looks easier than Eagle. There is no limitation on size.
Vias, pads.
Yes, pads and everything. And among that, you can easily save your. You can decide if you want to share your project in the community, or to, of course, download it in your laptop and then send it to the meeting machine. And at the same time, voila, this is the Chinese software. So of course they will ask you if you wanna to make it real with the company with behind it. That's it.
Okay, perfect. Okay, well, send us a link afterwards, even in the email, so we can share with the others.
Yeah. This is I already wrote it on the chat. But
perfect. I need to close the review now. So as I said before, I will inform you. I was gonna be now with Amsterdam for double review. And well, I see you later for the prep meeting with Neil. Okay. Bye, everybody.